This problem can change the way you think about problem solving. Hey everyone, welcome to Geomathic. What's the question? A big semicircle and two small semicircles inside it. The radius of this semicircle is 4 and the radius of this is 7. And of course, question says this line is parallel to this line. And we should find the radius of this big semicircle, means this line. First of all, I want to label this point A, B, C, the center of the big semicircle as O, the center of this M, and for this one N. And of course the point two semicircles touch each other P. Okay, the two semicircles touch each other at the point P. So a straight line through P like this is tangent to both semicircles. So the radii, this radius and this one, at the contact point are perpendicular to this line. I draw them and explain again. This is the radius of this semicircle. And this one is the radius of this semicircle. As we said, the radius is perpendicular to the tangent line at the contact point. So this radius is perpendicular to this line at this point, and of course this radius is also perpendicular to this line at the same point, which means this line is a straight line. So MN is a straight line. You can see MP and MA are both the radius of this semicircle, so they are equal. This line equals this one. Then if I connect A to P, I make an isosceles triangle. So draw it. Now I made an isosceles triangle in which two base angles are equal. I name this alpha here and alpha here. And now if I name this angle as X, then alpha is equal to X over 2. Why? Because the exterior angle is equal to the sum of the opposite interior angles. And we know in isosceles triangle, base angles are equal. So alpha equals X over 2, or X equals 2 times alpha. Then a straight line cuts two parallel lines. Corresponding angles are equal. So if this angle is X, this angle is also X. And we do the same thing for this semicircle. So I draw CP like this, and since this line NP and this one NC both are the radius of this semicircle, then they are equal. This line equals this line. And now again I've made an isosceles triangle in which two base angles are equal, and again the exterior angles of a triangle equals the sum of two opposite interior angles. And since these two angles are equal, so both of them are equal X over 2, which is alpha. So alpha here and alpha here, and you can see these four angles here are equal. In the next step, I draw a line from the center of this big semicircle to point C on its circumference. I draw that and I label this angle as theta. Of course, we know the angle at the circumference here is half of the central angle over the same arc. That same arc here is CB. So theta is twice the alpha. So I write this, theta equals 2 alpha. And we know 2 alpha equals X. So theta equals X. I write here theta equals X. And corresponding angles theorem says if two lines make equal angles with third lines, here is AB, so they are parallel to each other. MN is parallel to OC. I show it here. MN is parallel to OC. And I write here MN is parallel to OC. And of course, given information says NC is parallel to OM. So I write this, NC is parallel to OM. No, because MN is parallel to OC. And of course, NC is parallel to OM. We are dealing with a parallelogram. And in any parallelogram, the opposite sides and angles are equals. This shape is a parallelogram. So in any parallelogram, opposite sides and angles are equal. So OC equals MN, and we know OC is the radius of this big semicircle. So OC equals MN equals R, and MN here equals this radius plus this one, means 4 plus 7 equals 11. Then the radius of this big semicircle equals 11. Thanks for watching, and if you have any different solution in mind, I would love to see it in the comments. Have a good time.